In the 1860s, survey crews measured the Platte River at Cozad, Nebraska at 1,161 meters across. Shallow, braided, constantly rearranging itself. A river so wide and so flat it had no single defined channel. Just a shifting maze of sandbars and shallow water rebuilt every spring by snow melt floods off the Rockies. By 1979, that same reach measured 110 meters. 92% of the active channel was gone, not drained, strangled. Trees had colonized the sandbars the river no longer had the power to scour. Those trees trapped sediment. The sediment raised the islands. The islands fused with the banks. And decade by decade, a river that once spread more than a kilometer wide was compressed into a forested trench. For 35 years, conservationists fought that compression with bulldozers, industrial disc plows, chainsaws, herbicide, and controlled fire. They ripped trees from the channel, they scraped islands flat, and every growing season, the moment the machines paused, the vegetation returned. The river couldn't hold itself open. It was a patient on mechanical life support, and the bill never stopped growing. The question was whether anything could hold this channel open permanently, or whether this landscape would require human machinery running in perpetuity. In January 2015, 39 bison stepped off a livestock trailer onto a river island that 3 decades of clearing and $124 million of water engineering had painstakingly rebuilt. They weren't the first tool applied to this river. They weren't even the most expensive, but they were the one designed to make everything else finally stick. Before European settlement, the Platte was a different kind of river entirely. Up to 2 kilometers wide in places, rarely deeper than 2.5 meters, with spring snowmelt floods violent enough to tear establishing plants off the sandbars and reset the entire channel geometry every year. That annual scouring kept the sandbars bare, the channels wide, and the sight lines open across a vast treeless floodplain. 3 forces maintained it together: the floods, periodic wildfire, and the constant grazing pressure of millions of plains bison moving across the landscape. Then, across roughly a century, humans systematically dismantled all 3. Irrigation ditches siphoned water starting in the late 1800s. Massive reservoirs, Lake McConaughey chief among them, impounded the spring snowmelt by the 1940s. Groundwater pumping accelerated through the mid-20th century. By the time hydrologists measured the cumulative effect, upstream diversions had reduced the river's annual flow to roughly 31% of its historical volume. The scouring floods, the engine that kept the whole system open, were gone. Without them, a feedback loop locked in. Eastern red cedar, cottonwood, and invasive reed grass colonized the exposed sandbars. Roots armored the sand against weaker flows. When lesser floods arrived, vegetation slowed the current, forcing it to drop its sediment directly onto the islands. The islands grew taller, wider. They merged with the banks. Each year of narrowing reduced the river's remaining energy, which allowed more vegetation, which narrowed it further. The system was maintaining its own collapse. In 1978, the federal government designated the Platte as critical habitat for endangered species. Suddenly, the stakes weren't only ecological. Water agencies across Colorado, Wyoming, and Nebraska faced federal injunctions. The possibility that their irrigation diversions would be curtailed unless the habitat recovered. A multi-billion-dollar agricultural economy depended on reopening a river that physics was actively sealing shut. So the mechanical fight began. A conservation trust, formed from a legal settlement in 1978, sent bulldozers onto the islands to rip out mature trees. Industrial discs shredded establishing saplings. Herbicide was sprayed from aircraft to kill the deep root networks of invasive grasses. Controlled burns swept through the floodplain. Where the adjacent meadows needed grazing to stay short and open, managers leased the land to cattle ranchers. 35 years of that work kept the river from closing entirely, but it suffered a structural flaw. It treated symptoms while the cause, the missing hydrology ratio, remained. Every year, the machines paused, regrowth started, and the cattle introduced their own damage. They congregated at the river's edge, compacting banks and stirring sediment into the channel. Their diet was indiscriminate. Research showed cattle suppressed native wildflowers alongside grasses, flattening the meadows into something biologically simpler than the landscape required. What the system needed was the animal that had co-evolved with this exact grassland over tens of thousands of years. An adult plains bison stands nearly 2 meters at the shoulder and weighs up to 900 kilograms, the largest land animal in North America. Stocky, hump-backed, built like something scraped off a cave wall rather than anything you'd find on a modern ranch. But the engineering is what sets them apart from cattle. Bison are grass specialists. They target dominant cool season grasses with a heavy shearing bite and largely ignore broadleaf wildflowers. Where cattle flatten everything uniformly, bison open the canopy. Tall grasses get cropped short, flowers explode into the gap. The result is a patchy, uneven mosaic of short grass, tall forbs, and bare ground that no mowing schedule replicates. Their movement diverges from cattle in a critical way. Bison forage across vastly larger ranges and don't congregate at the water's edge. They tolerate summer heat without needing shade from riverbank trees. The banks that cattle trampled into compacted mud, bison largely leave alone, and their wallowing, rolling in dry earth to shed winter fur and deter insects, gouges shallow depressions that fill with rain and hold water for weeks, creating temporary breeding pools for amphibians and aquatic insects that the prairie hadn't produced in decades. Getting them to Nebraska was its own engineering problem. The only genetically pure plains bison remaining in the country, descendants of the Yellowstone herd, carry a livestock disease that causes spontaneous abortions in cattle. Moving them into the agricultural heartland was a non-starter. A reproductive specialist at Colorado State University solved it by washing bison embryos in a laboratory, stripping the pathogen at the cellular level while preserving the Yellowstone genetics intact. On January 17, 2015, 39 of those animals, cows and calves, were released onto Shoemaker Island in the middle of the managed reach. 2 bulls joined them shortly after. 41 bison total, placed on 1,200 acres of land that humans had spent 3 decades clearing by hand. But nobody deploys 41 animals on a river that 3 states have spent $124 million to rebuild without a larger question in play. The water program, launched in 2007, was already injecting up to 120,000 acre-feet of artificial flow annually. Controlled pulse floods to scour the sandbars the way snowmelt once did. The prescribed burns continued. The bison were the biological layer placed on top of all of it. For 35 years, the restoration had been a construction site. Machines maintaining a width, the river couldn't maintain itself. The bison were the test of whether it could become something else entirely, a system that generated its own maintenance. Within the first growing season, the difference was visible from the ground. Cattle had left a predictable pattern across these meadows. Cropped uniformly near water, overgrazed along the banks, largely untouched on the higher ground where they didn't bother walking in summer heat. The bison reversed it. They pushed into the uplands, targeting the dominant grasses, and left the riverbank margins alone. The trampled shorelines that cattle had compacted began stabilizing within months. 900 kilograms on sharp cloven hooves does constant, low-level work on the soil. It breaks up hardpan crust the way a mechanical disc does, except it never shuts off, never needs refueling, and covers ground in patterns no tractor operator would follow. Where the crust cracked, water soaked in instead of running off. Dormant seeds, native grasses, and wildflowers buried for decades under compacted earth began germinating in the loosened soil. The wallows appeared almost immediately, shallow, compacted bowls scraped into the prairie by animals rolling to shed winter fur. After spring rains, those bowls held standing water for days, sometimes weeks. Plains leopard frogs colonized them as breeding pools. Aquatic insects followed. A network of temporary wetlands materialized across the meadow, created not by engineering, but by an animal scratching its back. See, the mechanical approach had maintained the channel's width. It held the geometry open. But it had never produced this, the fine-grained, constantly shifting patchwork of short grass, tall flowers, bare dirt, and standing water that the prairie had evolved around. The bison were generating habitat complexity that no mowing schedule could replicate. But the deployment carried a cost nobody predicted. 4 years after the release, researchers monitoring grassland nesting birds found that bobolink populations inside the bison pastures had crashed. Abundance down 62%, nesting productivity down 84%. The same species remained stable in adjacent fields grazed by cattle. The cause was straightforward. The herd had grown from 41 to over 100, still confined within 1,200 acres of fencing. The stocking density was too high. The trampling that aerated soil and created wallows was also crushing ground nests. The bison were doing exactly what they'd evolved to do, but they'd evolved to do it across a continent, not inside a property line. Managers responded with annual culling sales and expanded rotations. The paradox didn't invalidate the approach, it sharpened it. Deploying a 900-kilogram landscape engineer inside fences means humans must artificially manage the spacing that open prairie once provided for free. The bison do the work, people manage the boundaries. By the end of the first 5 years, those original 39 animals had grown into a herd of 148, cycling nutrients, suppressing woody regrowth, and maintaining open sightlines across the meadows without a single pass of a tractor. The mechanical foundation was still in place. The water program still pulsed artificial floods every spring. The prescribed burns continued. But for the first time in 3 decades, the biological layer was holding its gains between human interventions. The meadows weren't reverting the moment labor paused. That mattered enormously, because this river wasn't just a river. It was infrastructure for something far larger than anyone watching the bison graze would have guessed. Every spring, roughly 80% of the world's Sandhill crane population funnels through a single corridor, not a flyway in the general sense, a specific 80-kilometer stretch of the Platte River between Lexington and Chapman, Nebraska, where the birds stop, rest, and refuel before continuing north to Arctic breeding grounds. They arrive in late February. They stay for weeks. And during that window, the river must provide 2 things simultaneously: wide, unobstructed channels of shallow water for nighttime roosting, and adjacent grasslands rich enough in invertebrates, amphibians, and waste grain to power the next 1,000 kilometers of flight. The channel width isn't optional. Cranes roosting on sandbars at night depend entirely on clear sight lines to detect ground predators, coyotes, bobcats. Research shows they strongly prefer channels wider than 131 meters, with large flocks requiring widths above 275. Below those thresholds, the birds won't use the roost. When the Platte narrowed to 8% of its historical width in the worst reaches, it didn't just lose water. It lost the geometry that made the river usable. This is what the 35 years of clearing, the water program, and the bison had actually been rebuilding. Not a river in the abstract, the densest crane staging ground on Earth. And running through that staging ground every spring was the most fragile thread in North American wildlife. The whooping crane, the tallest bird on the continent, standing nearly 1.5 meters, brilliant white with a crimson crown, had collapsed to 21 individuals by 1941. 14 breeding adults. Every whooping crane alive today descends from that bottleneck. They breed in northern Canada, winter on the Texas coast, and fly 4,000 kilometers between the two. The Platte River is their critical mid-route refueling stop. Migration has historically accounted for the majority of the species' annual mortality. Without functioning habitat along this stretch, the losses in transit would overwhelm the gains made at either end. Now, in 2019, the program nearly lost its congressional mandate. Water targets hadn't been fully met. The remaining shortfall would cost an additional $40 million, and program directors publicly called the figure infeasible. A rare bipartisan vote at the end of December 2019 secured a $156 million extension through 2032. The river survived its political bottleneck. The bison kept grazing, the pulse floods kept running. By 2024, the herd had reached roughly 170 animals, managed through annual yearling sales that made the biological program economically self-sustaining. The meadows they maintained, short grass, tall wildflowers, scattered wallows filled with breeding frogs, were producing habitat at a quality the mechanical approach alone had never achieved. In 2018, researchers documented something never previously recorded on the Great Plains: an adult whooping crane hunting juvenile catfish directly from the restored shallows of the Platte. The channel wasn't merely providing a place to sleep, it was functioning as a productive food source for the first time in living memory. What began as a channel width problem then became a vegetation management question, had revealed itself as the reconstruction of a continental migration system, one whose daily maintenance rested on animals that weigh 900 kilograms and have absolutely no idea what they're protecting. On March 17, 2025, an aerial survey team counted 736,000 Sandhill cranes packed between Chapman and Overton, the 80-kilometer stretch the program manages. The count shattered the previous record of 670,000, set in 2019. And because thousands of birds had already departed the river to forage in northern cornfields before the survey aircraft arrived, biologists confirmed the figure was almost certainly an undercount. 750,000 birds concentrated on the same stretch of river that had lost 92% of its channel width 4 decades earlier. The same geometry that bulldozers fought to reopen, that $124 million of water engineering rebuilt, that 39 bison were deployed to maintain. The river is not cured. The upstream dams still stand. The diversions still operate. The Platte will never recover the continent-shaping floods of the 1860s. This is managed recovery, artificial pulse floods, prescribed burns, and biological grazing holding entropy at bay across an 80-kilometer corridor. The bison don't make the program unnecessary, they make it sustainable. They hold the woody regrowth back between burns, maintain the grassland mosaic between pulse floods, and generate the habitat complexity, the wallows, the short grass corridors, the wildflower patches, that no machine schedule has replicated. Put it this way, the entire system costs roughly $12 million a year, split between the federal government and 3 states. For less than the cost of a minor highway interchange, it sustains the largest crane migration on the continent. 39 bison, 736,000 cranes. But the species that drove every dollar, every legal battle, and every hour of bulldozer time was the whooping crane. From 21 birds in 1941, 14 breeding adults clinging to the Texas coast, to 557 individuals by January 2025. A long-term growth rate of just over 4% per year, with 41 new juveniles recruited in the most recent season. The recovery spans 3 countries' worth of protected habitat, from Wood Buffalo National Park in Canada to the Aransas Refuge in Texas. But the Platte is the energetic bottleneck, the mid-migration link without which the corridor doesn't function. 21 became 557, and part of what holds the line for them, part of what keeps the sandbars bare, the meadows short, and the sightlines clear, is the daily work of 39 animals that arrived on a freezing January evening and never stopped grazing. Sometimes the most powerful engineering isn't what you build, it's what you put back. If this kind of engineering interests you, where landscapes break and where they get fixed, subscribe. We cover this every week.